right, here we go. Question 21 from our Precalculus, homework number 12 in MyLab Math. They want us to write the partial fraction decomposition of the given rational expression. So the first thing I want to do is copy this rational expression over into our scratch work and show you how to solve the problem. So when we're trying to take a rational expression and break it up using partial fraction decomposition, the technique that you use, the formulas that you use, depend on the denominator, and there are 4 scenarios. There's the case where the denominator has only non-repeated linear factors. There's the second case where the denominator has repeated linear factors. The third case is where the denominator has non-repeated irreducible quadratic factors. And then the fourth case is where the denominator has repeated irreducible quadratic factors. So this case is the first case. Here I can see in the denominator I have 2 factors, and the exponents on the variables are both 1, making these linear factors. So the formula for using partial fraction decomposition when you have non-repeated linear factors, non-repeated means that these linear factors are different, is you're going to separate into individual fractions each linear factor. So we're going to have a fraction that has only a denominator of x, and we don't know what the numerator is, so we're going to assign it a variable. Plus, we're going to have another fraction with the other linear factor, and the numerator is not necessarily the same as the other numerator, so we're going to assign him a variable of b. And notice that that does account for every linear factor in the initial rational expression. And now we need to solve this equation for a and b. Now, solving a rational equation means that we need to multiply through by the common denominator. So the common denominator for all 3 fractions is x times x minus 4. So we're going to multiply the left-hand side by the common denominator, and we're going to multiply the right-hand side also by the common denominator. On the left, the denominators cancel completely, leaving a 4. But on the other side, we're going to have to distribute to both fractions. So in the first fraction, the x's will cancel, leaving a times x minus 4. But in the second fraction, the x minus 4's cancel, leaving b times x. And so now that we've gotten rid of the fractions, we should be able to simplify this equation some. All right, so what we're going to have 4 equals, distributing a is going to give us ax minus 4a plus bx. And then notice I do have some like terms. I've got an ax and a bx. What I want to do there for those like terms is I want to factor out the x. And that will leave me a plus b times x minus 4a. Now, what I want you to notice on the left-hand side, there is no x term. So in order for the left-hand side to equal the right-hand side, the coefficient of x has to equal the coefficient of x. And from that, we can get an equation, a plus b would have to be 0. We also know for the left-hand side to equal the right-hand side that the constant has to equal the constant. From that, we can get negative 4a has to equal to 4. And then from that equation, we can solve for a. Dividing both sides by negative 4, that's going to give us a is negative 1. And then we can take that value, substitute into our first equation, and solve for b. So that's going to give us negative 1 plus b equals 0. Moving the negative 1 over makes it a positive 1. And now we have the values for a and b. And then if I scroll back up, we're going to know how to separate our original rational expression into separate fractions. Now, back to our MyLab math, we need to input the two separate fractions we just came up with using our fraction bar. The first fraction was a over x. A we calculated to be negative 1, so that would be negative 1 over x. And then plus, the second fraction was b over x minus 4. B we calculated to be 1. And then once I input both of those fractions, I'm going to be done. And so that's going to do it for this particular problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.